Good day, my amiable viewers. You're welcome back to class. As you already know, my name remains Israel Gwai. Today, we are going to have a look at a question in this that we are predicting for this forthcoming NECO exam. Please, let's get started without wasting time. NECO Practical Chemistry 2024. Solution A contains H2SO4 whose concentration is 4.9 gram per dm cube. Solution B contains S gram per dm cube of sodium tricarbonate 4. Put A into the burette and titrate it against 20 or 25 cm portion of B using meter orange as indicator. Record the volume of your pipette. Tabulate your burette readings and calculate the average volume of A used. Equation, that's the equation. From your result, calculate concentration of A mole per dm cube, concentration of B mole per dm cube, mass of salt formed when 500 cm of B is completely neutralized by A. Volume of CO2 liberated in C above at STP. These are the values you need to calculate. So this is the likely question we believe will come out. But make sure you study it very well. And before you start watching this channel, get your notes. As I always tell you, get your notes. That's your notebook, and start writing. Copy it out and start seeing how far you can solve it without even looking at this. God bless you as you do that. So to start this, remember in NECO they are very strict on it. If you want to lose mark, don't write. But if you know you want to get the free mark, it's a bonus mark, volume of your pipette, you must write it. That's where the mark start. It has always been like that, continue to be like that. It's a volume of pipette 25.0 cm cube. You can say 25.00, they give you the mark. But if you say 25, just 25, they won't give you mark. So that is that. Then you draw your table, say a titration table. Draw it like this. Usually they can give you 3 or 4, whichever, it doesn't matter. Just know what to do. You have rough, first, second. Indicate the unit. You don't indicate the unit, you may be penalized. Centimeter cube, centimeter, cubic centimeter. You now say final burette reading. Initial burette readings. Volume of acid used. So you see it. This is how you draw your table, a complete table, before you start putting in values. Ensure you put the final before the initial. So let's do the titration. Remember, you have to rinse this. Follow my first titration. I've already rinsed it. Follow my go and search it how to carry out perfect titration, draw a perfect titration table. All the precautions, they are there. Ensure you study that video very, very well. So this water, this solution A. Remember, you are putting solution into the burette. But still, I will still rinse it a little. So the first precaution, I always say, because of those of you that don't know the channel, just pour in little, allow it to pass through. We are going to use this. By doing this, you have rinsed a clean burette with the solution to be put in it. That's the first precaution. So before I now add the solution I actually want. Exactly 0. Remember it's solution A, which is the acid solution. Then the next thing is to use this solution B, the alkaline solution. Just insert it inside. You take a little. So this is how you rinse it. You want to make sure you turn it. The little is too small, so let's add it again. You can see it. This is where it is. You rinse it by the side, turn it, then discard it. I'm discarding everything here, so you can see it's pouring down. So this is how you rinse. But this you rinse it just once, and this you rinse it just once. After this, only the conical flask will be rinsing with clean water. Otherwise, also called can also be distilled water. So before I start, I have to rinse. Remember, I've rinsed the burette with the solution to be put in it. I have to rinse this one with water. Must always be neutral. Discard it. Then I now start my work. Exactly 25. Then I drop it inside. Ensure you are very steady when you are doing it. And remember, another precaution, must not blow the last drop with your mouth. Because the manufacturer has already made it such a way that the last drop will always remain there to make it exactly 25 cm cube. Remember again, you have to tabulate a base. Alkaline, you are giving solution B into this, not solution A. So that's, you can see the last drop is still there. So you can put a white tile or simply a white sheet of paper. In this case, I'm using a white sheet of paper. Put it under before you start your work. So this one is indicator, it's known as methyl orange. Methyl orange. Okay, this kind of indicator you just drop. 1, 2. 2 drops of indicator. That's what you are expected to add. So you can see it's yellow in color. Then I start my titration. You can see the color. I start my titration. I don't even need to look up till I produce a color change. Gradually changing. So you can see it's orange in color, orange. And the value I have here is 25.6. 25.60. I'll say rough. I started with 0.00, 25.60. You see, if you use 25.6, they will mark it wrong. You have to be 2 decimal places. Correct to 2 decimal places. Please don't start losing marks unnecessarily. No matter what you see in your textbook, those that are in the field, they always tell you what to do. So that is how it goes. Then you can refill it again. Remember, I'm doing 3 times refilling. Good, exactly 0 mark. That's 50. Then I'll start. Before I start again, I have to rinse this with water. Remember, it must always be neutral. So I rinse this with water. I don't need to rinse the pipette or burette again because it contains the solution into using them. Okay. I like to drain through. on its own. Must not blow its air and be haste. Nothing like that. In chemistry practical, we are very, very careful not to skip any step. Still draining through. Now it. Then we'll now add the indicator again. 2 drops. 1, 2. So let's start the titration. If you allow it to concentrate on one spot, you see the color will be changing on that spot. You still change it, then you return back, change and return back. That's it. So if you look at it, it has changed. The color changed at 25.3. 0.00. Let's do the last one. I have to discard it again. Check my first video on how to draw an accurate titration table to do you good. Okay, let's refill it again, so that if you like this now, since you already have about 25 point something, you must always refill. There's no way you can start from this. If not, it will exceed 50, and NECO will mark it wrong. Everything will be wrong, be marked wrong. Once it exceeds 50, you cannot use 2 separate burettes to get accurate results. It's over 0, so we have to reduce it to 0. Good. Remember, in this titration, you must remove air bubbles. When I did it, there was nothing like air bubbles. So check my previous video. Everything you need to know is accurately explained there. How to draw accurate titration table. Good. This is the last titration we are doing before we start calculations. So try and understand it properly as you progress. Remember, the end of the end point is orange in color. Don't forget that. 2 drops. 1, 2. It's not, if it has changed, it will return back. Change, return back. Start putting 1 drop. Good. It has changed. Then let's see the endpoint. 25.25. 25.3. Just take 25.3 for it. 25.30. So that's what you have. So you can do the fourth one. You are given 4 tables. So now we look at it. 25.60, 25.30, 25.30. You find the average. Remember, we are using 2 that are nearest, called them concordant. We pick these 2. So average volume of acid used, 25.30 plus 25.30 over 2 gives you 50.60 over 2, which is 25.30 cm3. This is how you draw an accurate titration table. I have this accurate average volume of acid used. Having done this, you don't need to waste your time or be praising yourself. Ensure you don't cancel any parts. If at the end of the day you mistakenly write this and you still used it, they will deduct marks from it. So don't lose your marks. So this is the table you are going to use. A similar table. Remember, in your school, most people give down their endpoints. In this case, you cannot copy what I have here. This is a teaching class. It's meant to enlighten you on how to carry out titration, so that you know the processes involved, not to take the endpoint. Endpoint of different schools differs depending on what you have in your school. That is how it goes. So we'll now clean it and start the calculations properly. You can leave that as a reference point. So you can see down. Let's go to the question. Tabulate your birate readings, which you have already done, and calculate the average volume of A used. We have already done that. Then, equation for the reaction. From your result, calculate the concentration of A in mole per dm cube, and they gave us A concentration of A in gram per dm cube. Remember, always watch out for, go through all my videos on titrations. It will do you good. Remember, this one is in gram per dm cube. If you are giving in 200 cm cube, you must convert first to dm cube before you do calculation. In this case, you don't have any conversion to make. This is in 1000. So you now say, you say concentration in mole per dm cube. You say concentration, that is question A. Concentration mole per dm cube equals concentration gram per dm cube times over molar mass. So you have gram per dm is 4.9, molar mass of H2SO4. Ensure you show them how it was calculated. Molar mass H2SO4. You say H is 2, they gave it to you here. Look at the values. Okay, H is not here. Usually H is 2. So you say 1 times 2 plus 32 plus 16 times 4, which gives 44.9 over 2 plus 32 plus 64. It gives you 4.9 over 98. Gives you, let's see what you have. 4.9 divided by 98. 0.05. That's what we have. So we have 0.05. If you leave your answer there, they will mark it wrong. You can never leave your answer at 0.05. This is one significant figure. It's not allowed in WAEC. So you now say, after writing this number, you now say 0.0500 mole per dm cube. Please don't lose your marks as my subscribers and students. So you have this. So that's the answer to question A. Then you go to B. Concentration of B in mole per dm cube. Since we don't have anything about B, we don't have any information, no value at all. So the only information left for us is to use the formula most students always call CAVA, CAVA over CBV. But the actual formula is CAV over CBV equals N over NB. But the student gave it a nickname, CAVA. It makes it to remember, my students. So you have, first of all, write the equation. You say equation H2SO4 plus Na2CO3 to give you Na2 SO4 plus H2O plus CO2. I think that's what they have. Yes, that's what they have. We now say mole ratio. You see, let your word be orderly. 1:1. You see it? Acid and base doesn't have business with this. So you now have, from applying the formula, CaVa over Cb Vb equals Na over Nb. If you watch my previous video, you know the names of all these things. That first titration we did. So there's no man for writing the names. So what you need to, let's write this value out. 25.30. That's value, so we can clean this. So you now say where, if you write this, it is easier for you. You hardly fail it. Ca, Cb, Va, Vb, Na, Nb. Ca is, we don't know. I think that's what it says you calculate. We know Ca. That's what we just did. 0.0500. As I told you in our previous video, always punch your calculator to 0 after writing the final answer. If instead of carrying this, you want to carry the previous one in your calculator, you may be wrong. They will mark you wrong actually if the values are different. Cb, we don't know. Va, volume of acid used 25.30. 25.30. Vb, okay, let's write the unit. Mole per dm cube, cm cube, 25.0 cm cube, Na 1, Nb is 1. You can see it. So having done this, you say substitute. Let's write it up because of the size of the board. Please follow the step properly. Say substitute. C is 0.0500 times CaVa. Va is 25.30 over Cb, which you are looking for. Vb is 25.00 equals 1/1. Cross multiply. Follow the steps. Don't jump at answer. Say I'm because of time. Follow the steps because these steps carry 4 marks. This one is already 1 mark. Correct substitution 1 mark. Make it to remaining 2 again. We say Cb times 25.00 times 1 equals 0.0500 times 25.30 times 1. Where's Cb? Making Cb solve the formula again, 1 mark equals 0.0500 times 25.30 times 1 over 25.00 times 1. You can see it. We have already used this one, so we don't need this again. So you now calculate. My dear student, follow these steps and try to do what is here. 0.0500 times 25.30 will give you 1.265 over divide by 25 give you 0.0506 0.0506 25.00 0.0506 mole per dm cube. Let's quickly cross check what you have. 0.0500 times 25.3 give you, divide by 25 give you 0.0506. So that is what you have in this second question of B, mole per dm cube. However, my beloved subscribers and viewers, this is where we'll stop for now. Let us call it part A, part 1. So you watch out for the second video because